Okay, we're going to start with review today. 1,103 times 59. I want you to do front-end estimation, which means round to the front number, and then you're going to send me your answer on your clickers.
So first, what we're going to do, we're going to want to draw the vertical number line. And we're rounding the first number, so we're going to want to put the 1 right there. And we're going to want to put the 1 parentheses 5. And then the 1 becomes a 2. And then we're going to come over here to 59. We're going to draw the vertical number line. We're going to put the 5 down here. We're going to do 5 parentheses 5. And then that becomes a 6. And then we come over here. Let's see if the 1 is less than 5 or bigger than or greater than 5. So the 1's less than 5, so it just stays the same. So it will become that number. Then we come over here, and then we look to see if the 9 is bigger, less than 5 or greater than 5, and it's bigger than 5, so that becomes 60. And then we do 6 times 1, that equals 6. Then we add 4 zeros to it. $60,000.
Okay, I'm going to have you click in. What's that answer? 10 to the power of 4. Remember, your number has an invisible decimal at the end. How many places am I going to move it? Everybody? 4 places. Which direction? To the right. The reason you don't want to look at it and say, I'm going to add 4 zeros, is because if you divided by 10 to the power of 4, you'd have to move this decimal to the left 4 places. So that's why you want to look at it like I'm moving a decimal. 1, 2, 3, 4. Now, someone asked earlier about 10 to the power of 1. Well, if I have this 10 to the power of 4, what am I doing with my 10? Well, what I'm doing is I'm going from one place value to another. So how do I get from 10 to 100? But tell me an equation that would get me from 10 to 100. No, that would get me to 20. What do you think? No? 10 times 10 equals 100, right? And what would that be? 10 to the power of 2. This would be 10 to the power of 3. And this would be 10 to the power of 4. And when I solve it, it should equal 100,000. But let's say I have ten to the power of 1 is 10, but what do you think this is? Yep. 10 to the power of 0 is 1. What? What do you mean everybody got wrong? No, in fact, actually, I didn't even know this until I started teaching that you could have a 10 to the power of 0, which would be 1. One of my 6th grade coworkers taught me that one. I didn't even know that, so there you have it. Okay, and I guess in that case you would remember zeros. I still think of it as adding zeros, but it gets a little trickier when you do division, doesn't it? Because then you're going the other way with the decimal. You're going to like this lesson today. Because this lesson today, look at your problem set, lesson 6. Number 1, page 2B50. Okay, this is a lot like what we did yesterday, but we're just kind of building onto it. So we would start with an area model. Where would I put the 48? Where would I put it? No?
You put it the 48.
Mhm.
You don't mess with it right now. You worry about the 35 because it's smaller than 48.
Okay, so you worry about the 35. So what do you want to do with the 35?
You take the 5 and 35 and put it next to the small box. And then you take your 30 and you put it right next to the really big box.
Because what is the value of my 3? 30. So then what do I do with my 48? Put it on the top. Now yesterday you learned that's it. But today we're going to take it one step further. We're dealing with 2 digits, right? So what if we did this? What do you think we would do on top? Why did I want to know there's 2 digits? What do you think? Turn to your neighbor, see what you think. What do you think I'm going to do with my 48? Number 22, what do you think? Okay, so I'm going to put the 4 over here, you think? And the 8 over here? It's not worth 4, it's worth 40. So what do you think I'm going to put with my 4 then? A 0. Talk to your neighbor. I want you to figure out what's going to go in all 4 of those boxes, and I'm going to have someone come up and write what your answer is.
Okay, so I did 5 times 40, which would be 200. And then we did 5 times 8, which would be 40. And then 40 times 30. And then 8 times 30. And then we added this side together, which would be 1,400. And then we added this side together. And then we added this to this, and we got this is our answer.
Okay, that's exactly the way you do it. So if you didn't get it that way, you need to be paying attention. Would it have made a difference in my answer if I would have put this second and that first? Would it have made a difference in my answer? No. The only thing you'd have to remember is that it's worth 40 wherever you put it. Okay? Would it have mattered if I would have added across first, 200 plus 40 and 1,200 plus 240? Would it have made a difference? Nope. I could have even done like 4 square. I could have added up all 4 boxes at once. That's, remember the commutative property where you can mix numbers and they'll still be the same, no matter which way you add them. So that's one way to do it. Raise your hand if you think you could do the standard algorithm of this number.
So you put 48 times 35. You do 5 times 8 is 40, so you carry the 4 over here. And then you do 4 times 5, and you get 20, plus 4 is 24. Then you put a 0. Then you do 3 times 8, which is 24. So you put the 4, cross the 4, and put a 2. And 3 times 4 is 12, plus 2 is 14. And you plus them, you get 0. And that's your answer. Same answer?
Okay, so we have this number on B, which should be a little interesting. $648 times 35. I want you to work with your neighbor and figure out a way to multiply this using the model, the area model. But think about the number, the last number we used had 2 digits and this one has 3. So think about how your area model might change. Talk about that with each other and solve it. Look up here. We're going to make our table. How many, guys, pay attention because a lot of you aren't getting this. How many digits are in my first number? 3. So I'm going to just go ahead and start by making 3 columns. What's my first digit? How much is it worth? It's worth 600 because it's in the hundreds place. How much is my second digit worth? 40. And my last digit is worth, everybody? 8. How many digits are in the second number that I have? 2. So I'm going to divide this into 2 parts. Which one goes on top? You can put the 5 on top if you want. 30 on bottom. And then you multiply. What's 5 times 6? 30, but don't forget your zeros. How many zeros do I have? 5 times 4 is 5 times 4. Add a 0. 5 times 8. Now I go to my next one, 30. 3 times 6 is, how many zeros am I going to add? 3 times 4 is, how many zeros do I add? 2. 8 times 3 is, how many zeros? So I can just add going straight down. I got to add 18,000 plus 3,000. Then 1,200 plus 200 is 1,400. 240 plus 40 is, so now what do I do with those numbers? Oops. Add them up. If you get confused when you start stacking numbers, just add 2 at a time. It's not a race to the finish line. Oh, I get a decimal in there. Is that the answer you guys got? Okay, on your homework, you need to draw the area model and then also do the standard algorithm. If the answers don't match, then you've done something wrong and you need to do it again because they should both match. So make sure you write down